Yeah. Hi, everyone. My name is Nikhil Barthwal. I work for Jet.com. So the way I've structured this talk, I'm going to give a very brief background of what Jet is, why we decided not to use an object-oriented programming language, a little bit about our implementation in F#, and the benefits that we had by using F#. Okay, so let's start with the background. We were launched in July 2015, which is like, the company started in 2014, but it was launched for the public. These are some statistics. We have 26 visitors per month, 25,000 orders daily, 8 million customers, and we have about 15 million items in our inventory. And last September, we actually got acquired by Walmart, 3 billion cash, 300 million stocks and something. So we were in news, everywhere, especially in New York City. Everybody was like, oh, you work for that company, the Walmart one. Anyway. Okay, sure. Thank you. Better? Awesome. So let's talk with architecture. We have microservices-based architecture, about 700 plus running in production. The reason why we used microservices in for our implementation, obviously we had a lot of scalability. Microservices lets you, it gives you the speed. It gives you independent releasability. You can scale down and scale up certain microservices depending on which ones are more heavily used. The ones like tier 1 that the customers generally interact with first, they can be scaled, higher in tier 2, tier 3, you can just tone it down a little bit. Fundamentally, it's an event-driven architecture. So when I say event-driven architecture, I mean it's kind of a reactive architecture where user generates an event, right? You go to a website, you order an item, you generated an event, order item to customer X, right? And obviously then the backend takes that event and it processes and goes through a series, okay, checks inventory, checks pricing, issues, does all kind of background checks. Event sourcing. So rather than using a state, we chose to use event sourcing because it can reliably give you 100% way of auditing and very good logs in it. So event sourcing, basically, for those who don't know what event sourcing is rather than having a fixed state that represents the system, basically what you have is all those events that you can replay to get the current state. So for example, if your system is not in sync, right? You got disconnected at a certain point, what was the last event. So you can just, replay the events and then get the current state by just summing up all the events that happened since then. Okay. So now comes the interesting part, right? We have the technology stack. So we were based on Microsoft Azure. There were business reasons. They don't want to have a competitor to Amazon running on Amazon platform for obvious reasons. No, there was a business reason, right? It doesn't make sense to have a competitor built on Amazon. So we use this .NET framework. There's a whole bunch of technologies. We have Event Store, we have Splunk, Redis, Kafka. We are going to we have now an in-house implementation of Kafka in F# called Kafka. So if you go to Jet GitHub site, you actually can download it. Earlier, we were using what was called as an RD Kafka, which is actually a C# client for Kafka, but we are heavy users of F#. Our backend is pretty much implemented in F#. I'd say front end, we have some TypeScript and Angular and a little bit of C# also, but backend is all F#. Okay, now let's actually go and look at what a microservice is. Or in general, I'd say this is probably true for a web service also, that when you look at web, it's basically, as I said, a function that takes an input event and responds. You can mathematically represent it as y is equal to fx standard. Vast majority of services are pure. And pure means you won't have any side effects. Here, when we talk about side effects, we are mostly referring to writing to a DB or something like charging your credit card. That's a side effect, right? Logging is not really, okay, in Haskell world, logging is a side effect, but we wouldn't call logging a side effect here because it's just, mostly for debugging purposes. And then you have some of them minority of web services where you actually use some kind of external effect like a writing to a database. For example, you want to check the inventory and you have ordered an item, so you want to go to your inventory DB and just reduce the count for that item, or you're charging the customer, so the customer's credit card gets billed. That's a side effect as far as the service is concerned. So before I go into why we used F# for an implementation, I'll first start by why we didn't use a standard C++ Java or the mainstream object-oriented programming language. So if you look at the history of object-oriented programming language, right, it comes from imperative. It was basically in around 80s that there was an extension made, and primarily object-oriented programming language brings two things to imperative world: polymorphism and encapsulation. And going back, the imperative world models the system as states, right? The Van Neumann machine, and you're basically manipulating the states of a Van Neumann machine. Thing is, microservices don't really have states, right? Vast majority of them are very pure. So it doesn't seem right to use a language that's primarily, architected around manipulating states for implementing something that doesn't have states in it in the first place. So now one may wonder why then vast majority of people then use Java or C# to implement. And my answer is, it's mostly historic. It's like, they are just mainstream and people think, hey, this is the way to do it. This is the way you do programming. Functional languages are not very popular. And then, of course, there's a large amount of ecosystem, right? You have third-party libraries and so on built in Java and C# that you can readily use. Turns out that most modern languages like F# and Scala, right, they can interoperate with C# or Java seamlessly because you're running on the same virtual machine. So we decided that object-oriented language are not the best way that we could do an implementation. And we had a lot of benefits that I'm actually going to cover in the later slides. And we chose to use F# on Azure. OK. So turns out that a web service can be modeled as using functional paradigm in a very natural way. For example, like I said, a service is basically a function, right, that takes an event, and algebraic data types of any F# can actually be used to model the event very well. We'll go through an example of how we do that. Each service can be viewed as a function that takes this event and generates an output. And of course, functions interwork with each other because especially in a microservice architecture, you have several services cooperating with each other. So function may call another function, it may call another function. So these are like nested calls. And event, when generated, don't change over time. So if you've ordered an item X at point T, you've ordered an item X point T, there's no chance that that's going to change. Now, you might order another item on a different time, yes, but that's not. Still, it's not the same event, right? Because the T is different now. So event by itself are immutable. And that's how it plays into functional paradigm, because functional paradigm has immutability built in. And this is actually a very important thing. It shouldn't be underestimated because it gives you an inherent ability to parallelize the code. We'll talk about it later. OK, so as I said, a service takes an input event, processes it, and generates an output. So you can model any kind of input event like, let's say that you want to query an item, right? So you want to query, I have this item name, or I have it from the catalog SQ number, right? Which is basically an ID assigned to each item. That's your input. Then you have an output saying, is the item in inventory? So you take, because your SKU number is basically an integer, so you say, well, yes, it is in inventory. It is not in inventory. And when you have it in inventory, you also want to know the count. How many items are there in inventory, right? It's not in inventory. I can give you an estimated date when it would be. So that's the second case. Or the third simple case is we don't carry it. Sorry. And then you have a function that can take this input and do all the processing and do the output. So here what I want to illustrate is how easy it is to define these events and write a function. So if you're like implementing your service, how you basically take it as, the way I would implement it is I would define what are my inputs to the service, what are my outputs, model them in ATCs, and then just write the code that transforms. Because one way of looking at functional paradigm basically is it's a series of transformations, series of functions that you apply to input to get an output. Okay. There are several advantages to implementing in functional languages, particularly if you try to stay with the immutable and purity part as much. Turns out that it's very easy to predict the behavior of the code if you stay in the purity limits. And you can test it exhaustively because there are no side effects, right? So there's nothing that stops you from testing it exhaustively, generate millions and millions of cases. I know John Hughes talked in the morning, right? They have this quick check and tools that can generate millions of cases. With impure services, there is a certain kind of, because there's an external state now, when you test it exhaustively, you have to be mindful that of your states, right? Your states have to be same because you can get different results at different point of time because your state was different. It's not easily visible to the user or the tester who's testing it. And of course, certain functions can't be tested exhaustively because if I'm testing, I'm not going to bill your credit card 100 times. So what were the benefits of using F#? The first thing is scalability. And this comes from immutability. The thing is that because F# is pure, there are no side effects. Writing scalable code is so easy. You can go from like, thousands of customers to millions of customers and not even feel a blip about it. That's where scalability by far, and for a website like Jet or Walmart, scalability is a very, very, very important thing. We talk about productivity. Typically, F# code, we find that it's about 20 to 30% more concise than an equivalent C#. Now, I know William Blum talked about type providers. And if you were to implement a type provider in C#, you're talking about 900 lines of code. And F#, it's 1 line of code. Because everything is done like automatically for you, right? You have a type provider for JSON, so it parses the JSON and it automatically deducts the structure and defines a type for you. You really don't have to do it anything manually, right? Of course, there is a pros and cons that, if the type provider, when you use the JSON that you're giving has to be representative of what you expect, right? If you have a field that was not present in the original type sample that you use, now you're in a little bit of problem. But the good thing is being statically compiled, you would detect a large number of such cases if you use your code, because you're going to try to access a field that already doesn't exist. So your code would not compile. And this actually leads me to my third point, code correctness. There's a saying in F# community, and I think it's probably true for most of functional languages. If it compiles, it's probably correct. And what it tells you is that most of your bugs that typically, like the null pointer exceptions and so on, assuming you don't use null in F#, you actually can use null in F#, you just have to explicitly mark it. But most of your bugs at runtime, through a very strong type system, actually is checked at the compile time. So you eliminate a large class of bugs that you would otherwise encounter at runtime by using a very strong type system that F# would provide you. And that's where the code correctness comes in. I'll give you some numbers that we, like, I don't know about Amazon's code base, right? But our code base is incredibly small, incredibly small. We are talking about maybe 50 to 100 MB, and I can bet you the Amazon Git repo probably goes into several gigs right now, mostly because they are using Java, and I know Java is the worst language because it's very verbose, but essentially it only highlights my point that it takes a huge deal of time for you to write that code, and it's a pain for you to maintain that code, right? When you have really concise code, it's so easy to write, so you have a lot of dev productivity, right? One guy can do like 4 people's job, and assuming that you use good enough compiler, right? Maintaining that code is easy. So, conclusion. Very few startups have scaled with jet size in the same time. I mean, we are talking about from $0 to $3 billion in like almost a year, year and a half. And I kind of toned down the statement very few because to my knowledge, I do not know of anyone like that, right? But somebody can audience say, oh, I know this, so just to give myself the room, to step back, I just changed the line and said, no, very few. So people don't yell at me that you're wrong. And at the time when we used F#, it was like I don't know if I'll call it a revolutionary. We are, again, I'm going to give myself that room to step back, but to my knowledge, we are the biggest commercial users of F#. I do not know of any other big company. I'm not talking about a 2% startup here, right? But I'm not aware of any big company that has practically all its backend implemented in F#. And obviously, because we are very much involved in the open source community for F#, if there was a company, we would have known about it. But since we don't know, so I'm probably going to say, safe to say that there doesn't exist one. And obviously, we have the scalability in parallelism and productivity, and all came because of F#. I'm open for questions.
I'm a developer of a startup right now, and we're thinking about implementing event sourcing, and well, would not say microservices, not yet, because well, you don't have microservices with one, right? But how would you start developing ground up the event sourcing, and how would you as a startup how would you do it?
Just a second, Nico.
Well, you have already used now. And that's particularly if you're a startup, right? So if Google wants to invest billions of dollars to have their own event sourcing, sure. But I don't know about your startup, but I would doubt that you could do that. So because of the interoperability of F# and C#, in a case like this, and in a case of several such instances where you would face, okay, how do I do it in F#? If you can't do it in F#, but you can find somebody who did in C#, that's good enough for you, right? And particularly for event sourcing, I do know that there is an event store. We actually use an event source, which is actually I don't know if it's a commercial or open source, but we use event store. If you just Google, you'll get that in our application. There were some issues with the reliability with event store, and we are trying to replace it. Now that we are big and we have money from Walmart, we actually are now thinking about implementing our own, but we probably still won't implement from scratch, right? We will still use some existing and customize it to our need. But to start, you can just start using event store or any C# library. And that should do that. But I definitely don't think you should start from ground
up. So you said that you have hundreds of microservices, and most of those services are pure functions, right?
That's right.
And it seems to me that there's a trade-off there. So if they are pure functions, they don't have any state, they could also be a library that you include in the services that actually have state. And the trade-off is the microservices that are pure functions are called over the network. So there are different distributed system problems that can happen there. Like the service can be down and so on. Network problems, right, stuff like that. Can you talk about that trade-off and why you chose the microservice way over libraries that are included?
Well, microservices actually has to do with time to market thing, right? With microservices, you can market fast. And again, now we are no longer a startup, but when we started, our goal was to just have a product the customers can use and generate revenue as fast as possible. And you would laugh at this, but we really didn't even have the testing infrastructure properly ready when it was open to public. It was really like, we just believed in it. If it compiles, it probably works, and we went with that assumption. Most of the time it worked, sometimes it didn't also. And now we are thinking of having unit test cases and all those things. In fact, we have open sourced another library for unit testing. But yeah, it comes from the fact that you you need a faster time to market. Now, in terms of your original question on you would have problems with networks and so on, but that's more of a problem that your cloud provider is supposed to solve for you than you are supposed to solve for yourself, right? So if you use a good enough, I mean, if you use your own private data center, then it's your headache. But for us, that was Microsoft's headache, not ours. So we would stay in the same region, we stay in the same data center, we stay in the VNet, and it kind of worked. Yes, you have production outages, but hey, everybody has a production outages, right? And often we were a premier partner of Microsoft, so if we have issues that were beyond our control, we would just call them, hey, fix that. But again, a short answer to your question, it's something that your cloud provider is supposed to give to you and not you're supposed to solve for yourself.
Hi, similar kind of question, I guess. You mentioned you have this huge number of microservices. I think you mentioned more than 700?
700. 700, when I prepared the presentation, it probably would be 720, but sure.
Yeah, so I guess my question is, when you have such a huge number of components, how do you make sure that they actually work together? I mean, if there were components inside a single service, you could rely on the compiler and the type system to tell you when you've made a mistake. But how do you actually make sure that the components work together when they're split across microservices?
Yeah, so that's a good question. And actually, that's a criticism of microservice in the sense that when you have a monolithic service, right, something happens, you get a nice call stack. Now with microservice, you have a problem that I put an event, it's going in an ether, right? I got a response, I didn't got a response, I didn't got a correct response, but I have no idea what happened in between. So yes, that is a problem. Now you can mitigate that problem substantially with how you write your code, how you test it. I mean, you have a whole bunch of integration testing, right? Staging environment where you deploy your code in. So that's supposed to actually mitigate the problem. Obviously, there's no way to guarantee a 100% success rate there, or like 100% way of you can get rid of all problem. But depending on how good your test environment is, you would be able to mitigate that problem substantially. Also, when you write your code, see, the way it happens is that you have 7 different microservices written by 10 teams, let's say. So let's say hypothetically you have 70 services by one team. There would be some similarity. So behind the code in your implementation, you actually are using the same common libraries. So that also reduces the chance that it won't work because the code might be deployed separately, but in terms of your code base, you're still using the same library across 70, right? So don't think of it as 700 different components. You could just boil down and say there are actually 10 different components, right? Split. Each component itself has 70 different subcomponents. Yeah. Yeah. Yeah, because you obviously, I mean, being a small startup, right? Think about it. Can you really have 700 different individual components? We don't even have 700 developers. We probably have like 100, 150 when they wrote that, right?
The question is, how do you monitor your entire system? Do you rely on Microsoft to monitor this, or do you monitor the microservices individually by yourself? How does it work?
We have to do it ourselves. So we have a logging library. How it works is that because we chose to go with F#, we did not had a lot of standard libraries that we can use that you could, get in Java. In Python you have logging infrastructure. In Java also you have. So we implemented a whole bunch of stuff ourselves. And this is an internal library that hopefully we would open source it for the community sometime in future. But we have a large infrastructure, common libraries for logging and telemetry and all this that we have implemented. And they will obviously output, and then the DevOps team has log rotations and all those things. And then we actually use Splunk for log management. So our data is actually sent to Splunk. And there we can just query and see if something is wrong, if that answers your question.
Okay, thank you. Final question.
Okay, I have one question which I probably didn't understand, and you were speaking about the services which are pure and services which have side effects. So it's like a reading from database and not modifying it. A pure service, like when I put the product name, and I read the details about the product. Is it a pure or impure in your sense?
So here's the thing. It depends on what you're reading. If it's an information that can change over time, then it's not pure because it depends on the state of your database. Now, for example, if you're going to give me how many counts of item do I have in my inventory, that's impure because as people purchase, your count would go down over the time, right? So it depends on the state of the DB that you're reading right there. But if it's something like, do I carry the product or not? Yes or a no. I mean, yes or fine. It's also somewhat impure in the sense that you can add new products in your inventory, but it's not something you do frequently, right? So for practical consideration, you can call it pure. Yes, if I upgrade my system and add 200 more items, sure, that can be called as impure, but it's not something I'm going to do frequently. But something like count of inventory, that's frequent because people are parallelly buying stuff, right? So essentially, when I say pure and impure service, the way I look at it is there a state involved that my output depends on? That's what it is. And is that state changing over time? If it's yes, it's an impure. If it's no, I'll call it a pure.
Great. So thank you very much, Nicole. Fascinating talk. Congratulations. There will now be a 20-minute break.